Forgot to hit record, so let me catch you up. The idea is that we're going to learn how to do one of many types of volumes, but right now I kind of gave you coming attractions. It amounts to if you take a region and revolve it around an axis, you get a three-dimensional figure. So this one, if you revolve X slices around the axis, you get disks. If you revolve in the second one, Y slices, then you get empty shells, and that would take a different approach. If in C there was a hole in the region, then you would get disks with holes in the middle, so they would be more of a washer method. And then the last case is if the region was the base of a figure, and then you built off of it, you would get different volumes. Now these are all things we'll learn this year, but the only one I'm going to do today is the first case, the disk case. So I have posed the question to the class, if you have the region closed by the square root graph and the axis ending at 9, and then you revolve it around the x-axis, then you get a solid of revolution. How do you find the volume of that solid? I told them think geometrically, then calculus. So think how you would estimate the volume first of all with a geometric figure. Think of what a slice was.
That's what was on that. So where were you
That should get you started. I'll turn it on back in a second. What type of shape, geometric shape is this? It's a cylinder. And I need to find not just one cylinder, but the many cylinders. How do you find the volume of a cylinder? Area of the base, because it's a circle, the area of the base is r squared, and the height. And the sum, I could say it's that, but I'm going to take the infinite limit of these. And so that, in calculus, is what? Yeah, that's that. Right? Okay? So we're almost there. The only details are what's R, what's H. Well, here's the radius of each cylinder. Is the radius constant or varying? Varying. In fact, it's tied to how high I go up. Well, how high I go up means I go up to the function, yeah? So it's the radius. The radius is just the function itself, yeah? Wherever the radius is just tied to whatever the function is at that point. So when I say radius squared, it's really the function. What about the height? It's not even barely, I want to add so many of these that they're so thin that they're almost circles, not even cylinders. It's paper thin. This cylinder is paper thin. What's the thickness then if it's infinitesimally thin? dx. dx. The height is dx. The limits of integration, what do they need to be? If the x's I get are from 0 to 9, then the x limits need to be 0 to 9. With that said then, if the function is the square root of x, and the radius is squared, then what's the antiderivative? Yeah, the function squared is just x, which is integrated is 1/x squared from 0 to 9. So my volume is 81 pi over 3.
What are we doing the other ones?
Shells are 87-ish, I think. Washers are 83-ish. Okay, now, complete this analogy then, please. Area under a curve is to the sum of infinite rectangles, as volume of revolution is to the sum of infinite disks or cylinders. The idea for finding a volume of revolution is to sum many cylinders. So the volume of a solid of revolution is going to be pi r squared h. And in terms of the pieces, the r will always be just tied to what the function is. And the height will always be barely thick dx. And the limits of integration will be for x, so I'll call it x1 to x2. And I would love for you, rather than to commit to memory, understand where it's coming from. You with me? All right. Now, if that's around x, then let's try a little different spin on it. Say you have the same curve, but now you're enclosing it with the y-axis and y equal 3, which is, oops, I missed. That's 2. Oh, that's 4. Sorry. Y equal 3 is there, and you're revolving it around the y-axis. So it's going to look like this, the reflection. Now, this is not the same figure, so do not expect the same volume. It's a totally different shape, so you should not get the same answer. But consider this time, to make solid disks, what you're going to have to do. If I use x, then a slice would look like this, and a revolution would actually have this huge empty shell shape. X isn't going to make a disk. Okay, when I say x, I mean the slice is barely dx thin, and when I take a rectangle that's oriented that way, I don't get a disk. So I'm not going to take a slice that way if I want to get a disk. In order to get a solid disk, I would have to make a slice this way, so that when I revolve it, then I would get a disk, and adding many. So you'll see then maybe a little different approach. Try this one. Now that you're revolving it around the y-axis, you're going to have to make an adjustment. Think about it, talk about it, and we'll go over it in 1 or 2 minutes. Good, thank you.
All cylinders.
That makes sense. You just asked for it. I know that's true. I used to think that only the separate my brain is screen everything and stuff. Now you're starting.
Probably 16 lessons to do the other types.
Could you do it for fun?
Which okay, so would you agree that the radius is constantly getting bigger, smaller, this and that? So there's actually 2 ways to think of radius. One way is to just say, all right, to get to the radius, I can just go into the curve. So I'm going to use the curve for the radius.
Yeah.
Okay. The problem is, though, that if the curve, or the height is a dy term, you're not going to be able to just throw that square into the radius because it's
Oh,
supposed
you're
to be a
doing
radius.
the line.
How do you-
I just did it in Yes.
Okay, so you're right to say you want to do what exactly the height of the slice you need. Okay. So just think of it as the curve. And the okay. All right, so it's, at least these people, they seem to know that the height is not dx anymore, the height is dy. And so that presents a little bit of a different animal. The height is dy. Now the radius is still, the way I still see this is the radius is still tied to going to the curve, right? I mean, I'm still going to the curve for the radius. The only difference is the curve needs to be, instead of in x terms, you need to put the curve in y terms. And so instead of y equals the square root of x, I'm going to say x equals y squared. So that when I say the curve is the radius, then I need to say y squared is the radius. The limits of integration, 0 to 9 now, or 0 to 3? 0 to 3, because the y region is 0 to 3, not 0 to 9. The y values are 0 to 3. What is the antiderivative of y to the 4th? 1/5 y to the 5th. What is 3 to the 5th? 243. So the volume of that is 243 pi over 5. You do not typically put units on these. They're not a big deal, but they are volumes, so if you wanted to say units cubed, that's what they would be. Okay? So the deal is this then. If you rotate around the y-axis, then the volumes of pi r squared h's aren't going to be h's of dx. The heights will be dy. And the radius, instead of the curve in x terms, it'll have to be the curve in y terms. And that'll often involve finding the inverse of the original function. But the function in y terms, and it'll be with y limits of the region rather than x limits of the region. Does that seem to make sense? Okay. Try these, this problem on the back. These then gradually add a little complexity, and maybe we'll see. Also be ready to move if they call it in a couple minutes. We'll start to move over. All right? Oh, sorry. I'm going to throw this section. Here's your 671. Oh,
Oh my God.
yeah.
Good afternoon, faculty, staff, and students. We are beginning a lockdown drill.
All right, here we go.
Lockdown. Lock, light, out of sight. Lockdown. Lock, light, out of sight. Lockdown. Lock, light, out of sight.
Close on the door, so don't freak out when you hear that. I'm going to say they're police, but you're not supposed to believe them.
great. Great job. Can't see anybody, staff member closest to the door, everybody's down low. Great job. My name's Tony, I'm with District Security, guys. I'm here to talk to you real quick about lockdowns. All right, first thing I want to cover is cell phone use. If I called everybody in this room, would anybody's phone ring? All right, phones are off or on silent during a lockdown. It's okay to text. You can text your parents, let them know you're okay. You can even send a text to 911 now. That's a relatively new feature. Okay? I want you to understand why that is. This is a drill, and everybody knows it's a drill. If something real were to go down here, word gets out on the street, something's happening at the end, what do you think happens next? Everybody you know is going to try to call you and find out if you're safe. All right? We want to make this room look vacant. Somebody walking by looks in the window, thinks there's nobody in here. That can't happen if phones are ringing. All right? Next question. You're locked down like this, firearm goes off. What do you do? Stay put. Okay? It's the one time you get to ignore a fire alarm. It's highly likely in an actual school emergency, somebody will pull a fire alarm and try to get people to run around. Don't fall for that. Unless you see flames or smoke gets so bad that you have to evacuate, just stay where you are, wait for the good guys to come. All right? Don't open the door for anybody. We're always going to have a key when it's time to let you out. All right? If you did have to evacuate, let's say you were out in the hall, you're down at the restroom or whatever, we expect that door to be locked quick. You may not be able to get into a classroom. Evacuate yourself. Get out of the building. If you did have to evacuate, crawl out a window or something like that, where would you go? Where's your evacuation site? Anybody know? Okay, so that would be for a fire drill, you know, but if we had an actual school emergency, like a school violence event or something like that, we have a designated site, and we'll cover that at staff meeting or something, all right? That's something that the students could be aware of too. Get to a safe place. Go home. Go to any place where there's adults. Call somebody. Let them know you're safe. All right. Last thing I want to talk to you about. Not something we like to think about. Not something we like to talk about. Okay. But if you're locked down, we do these drills for a reason. All right. Take this stuff seriously. Average lockdown in an actual emergency is going to be about 6 hours. So you need to be prepared to sit tight for a long time. Okay. But if you are locked down and somebody tries to breach that door, you have the right to do whatever you need to do to stay safe. Barricade the door, crawl out the window, fight if you're capable of doing that. But think about what strategies you'd use in an actual event to keep yourself and your classmates safe. All right? Remember what I said about 6 hours, guys? Because it's a drill, we can announce on the intercom that we'll release from the drill. But get some good practice in, stay locked down until the drill's over, and we'll let you know with an announcement. Good job, sir. Thank you.
I don't think they say they don't take the bullet, I guess.
Can we get through Sebastian's on there?
afternoon, faculty, staff, and students. Thank you for your time during the lockdown drill. The drill is now over. Teachers, students will stay in their 6th period class, but please give a 5-minute break to 2:10 for students to gather things they may need for the end of the day. Thank you.
Yes, thank you. Anybody else has a check out, let me know.
Well, we're gonna get the problem solved.
Oh, that's right.
Well, we're the same thing.
Oh, and I recorded that whole lockdown drill. That's super.
You did.
Yeah.
Great.
Told myself, hey, don't pause that.
Well, if anyone
Well, that's an
missed
exciting.
their lockdown drill, but they could hear that speech.
Yeah.
That's scary. Like those moments when someone's like, yes, I can see your boss. It's like, betrayed. So very clear. So I like that stuff. Maybe I'll.
Oh, yes. Okay, so that just drops that. So you do the 1 and then 1, so 8 minus. Inverse tangent of 1 minus inverse tangent of -1. Later.
Okay, that's just I see what you're doing.
So what did you do? 8 minus pi 2. Yeah. So what is it? 8 minus pi over 4 plus. Yeah. Oh, cool. Okay. I was like, that sign's going wrong. Okay, so we'll do this. So do. I know, we were going to try to get some in y equals x squared. And then you could want to get it.
Just gonna put these up and see if people have questions.
What is that?
What? Oh, it's beef. It's a pork and chili. Yeah. I did not eat lunch. Oh, I still have a recording. I thought I recorded. All right. I'll put the answers to those 4 problems and you can check and ask questions at your leisure and then work on whatever you want to work on, okay? For the benefit of the notes. Oh, sorry. You want some? Oh, okay.
Oh my God, you don't even know.
Are you starting? I don't have.
Yeah.
Oh, good.
What?
Nothing.
I still
Hi.
Is that a fire or yes?
Thanks. Oh, you have this permit with you. So you staying in your room by yourself?
I was down making copies when that happened.
Didn't you know? Or you wanted to be
I don't know, I thought I'd be able to get things done. I wasn't paying attention to the time. Oh, crap.
I just finished it.
Is that okay with you guys? Do they look in the office?
It's in his.
Oh, kindergarten corner up in the light.
No, it's not.
Oh, yeah. Oh, the hit stuff.
Yeah.
Oh, how bad.
I just read around education. It's level the playing field. It's not give a kid who wants an advantage an advantage.
Yeah,
There's a difference.
that's interesting. What?
And you're looking at my work.
Oh, that is cheating. Did you get 64 pi over 5 for the first one?
Yes.
Okay. I also actually said you may use your calculator, so if you have a decimal, that's fine too. I really, for the most part of these, I want you to focus on the setup of it. I know you can integrate when you need to, so the setup is what I like. How about this guy? This one was different in that, first of all, the more graphs you throw, the more complicated the region is to identify. So here, if you look at the 2 graphs intersections, you actually have multiple regions you could consider. You have to read very carefully. The curve, the line, and the x-axis, this is the region that's being revolved, that quasi-triangular region, all right? So make sure you identify the region correctly. If you identify that correctly and revolve it, the next issue is that the disks are not always the same radius. That one's different in that the function, the radius that's the function, hands off from the parabola to the line. So to deal with that, just like you would in areas, if you have 2 areas, you need 2 integrals. Same goes here. You'll need 2 integrals. You would go from 0 to 2 on x squared, and from 2 to 6 on the line
What did you say?
squared. Yeah, because the radius is different in different places. So that would be the setup there. The one here, I assume you graph the region okay here. That's fine. The y-axis is fine. And y equal 1. So here you're talking about this region. There. If you then revolve it around the y-axis, that's these kind of disks. When you revolve it around the y-axis to get disks, you have to do horizontal slices to get horizontal disks. So because of that, then these will be y. So you have to take the curve and put it in y terms, which would be 4 minus y square rooted, yes? That, though, is radius squared, so that would be then squared. The limits of integration would be from 1 to 4. Did you get that one right? Yes? No? Are these set up right? Okay. Okay. And then the last one, you have y equals x squared. You have the line and the y-axis in the first quadrant. So that, again, is that region. If you revolve that around the y-axis, then you're going to get y-type disks, but this is a 2-region case, so you should get, oops, I'm going to the wrong thing, 2 regions.
Students that have not had their picture taken yet for this school year, please go to the auditorium for some pictures. If you have already had it and don't like your picture, that's October 5th. Please do not go down there right now.
And that would be the case for the last one. So those are all the ugliest kind of cases for now. That should be a pretty good exhaustive set of notes. If you use those as a reference, that should be good. With me? Yes.
Are we going to be graded on our sketches?
I require the sketch, but I don't grade you on the quality of your sketch.
So if it's like not to scale, then that's okay.
Not to scale is okay. If there's effort there, the only reason I've taken off is people obviously gave me this garbage. You know? So if you're trying, that's good enough for me. Okay? It's not up class, although they do look pretty cool when they're done really well. All right, that should be good. That's all we got to.